Hi, morning all. Today we are going to discuss about transient response for RC circuit. I think for the last class we have discussed about RL circuit. So in that we are discussing what is inductor, how we are connecting and the DC supply along with the resistor that we called as the RL circuit, and what will happen after closing the switch, the equations and applications, all those things we discussed in the last session. Likewise, we are going to discuss in this session about RC. And we know that the capacitor equation is I is equal to C into dV by dt, and it stores energy in the form of electric field. And these are the topics we are going to discuss, that is charging process, Laplace method, and inverse Laplace method, capacitor voltage response, time constant, and applications. And this is a circuit we are connecting both resistance capacitance along with the DC excitation circuit. In that we have to notice there is a switch is there. When it is initially it is in the open condition. When it is closed and the circuit considered as the closed circuit, definitely there will be a current flow in the element. Then what will happen, that we can discuss in this equations, that is V of t is equal to V into U of t, and output of the capacitor voltage is V is equal to R into dt by dq plus CQ, C into Q. And they were taking Laplace for this equations, so V by S into RI of S plus I of S by C of S. From this we are calculating the value of Vc, that is capacitor voltage, is in the form of phase domain, that is V divided by R and S into RC into S plus 1. And taking an inverse Laplace form, that is before going to the inverse Laplace form, definitely we have to take the partial fractions, that is V into 1 by S minus 1 by S plus 1 by RC, and the inverse Laplace is V of Vc into T, which is equal to V into 1 minus E of minus T into, sorry, minus T divided by RC. That minus will becomes under the, based on the minus here we have to put minus also, that we consider that is that is here plus we are putting the minus. So there is a response of RC circuit, and so if there is a suddenly change in based on the input in the circuit, it reaches the steady state condition after a few time, that is t is equal to 0, or t is equal to 1, t is equal to 0, 2, t is equal to 3, and it will be reaches the steady state. This is shown in the circuit. This we called as the critically damping circuit, that is critically damping represents, and it is clearly show that the response of characteristics at t is equal to 0, t is equal to infinity. T is equal to 0, the Vc of 0 is 0, that is here it is comes, and then the t is equal to infinity, it will be reaches the voltage and the time constant R into C. And this is the based on the current, that is current when it is starting, it is in the maximum, and after that it will be decreasing, that is charging and decreasing will be happen in the capacitor. So this shows the diagram when t is equal to 0 and t is equal to infinity. When t is equal to infinity, the circuit reaches charging maximum and it comes under the steady state. This is the empathic part and the defined part. And for the application for the real world for RC is camera flash charging, timing circuit, filters, and power supplies. This is the summarization. What are the points we discussed? What is capacitor? How it is connected in the R and RLC along with the battery. What will happen after closing the circuit, and Laplace form, inverse Laplace form, and characteristics of equations and time constant, and also the applications. And these are the few reference for your here I mentioned. And thank you all. I think the session is useful for discussing about R and C are connected in series. R and C are connected in series means we are discussing what will happen in the transient. What is meant by transient? Transient is the response based on the response in the circuit based on the input changes. So based on this, we are analyzing how it comes the steady state. Thank you all.